everyone. It's 12:30, so I'm going to start the lecture so I can go through more examples. And as I said, when I'm teaching, if I hear people talk, I just ask them questions. So before I start the lecture, your SI class leaders have announcements to make. So let's listen to them.
Okay, so you guys filled out this survey about extra credit on Monday. So now going to SI class will give you 5 points for every hour that you go. All of the hours for everybody that's been in the past are also going to go in as extra credit. And just if you plan to come to SI class, just make sure to be ready to participate.
And today for my session, I'm going to be focusing a lot on writing ionic compounds and molecular compounds, along with calculating atomic mass and some dimensional analysis, since you'll be using that quite a bit.
And I'm going to be doing similar stuff and also going over some of the stuff that's on the homework list too.
Okay, thank you.
Yes.
Okay, and you guys can see the hours on the board. So just, if you weren't sure about the hours, just email me. You also have those in syllabus and course schedule. Are they the same? Okay. But feel free to reach out to me or your SI class leaders if you have any questions. So before I start the lecture, do you guys have any questions about what we learned in the last class? And as I mentioned, from now on, the course is going to get much more difficult. So many confusing things. We have molecular compounds, ionic compounds, different types of ionic compounds. So even if you weren't studying so far and you were doing well, I advise you to start studying, because if you don't, it's likely you don't pass the class unless you know the materials beforehand, which I think is unlikely, otherwise you wouldn't be here. Okay, so we talked about halogens in the last class, and now I'm going to finish by group 4A. And if you learned the elements that I told you before, now you have a good understanding of the elements. So group 8A, helium, neon, argon, krypton, xenon, radon. So make sure you know these elements. And can anyone tell me what type of, in the category that we had atomic elements, molecular compounds, ionic compounds, what type of these elements would form? Would they be atomic elements, molecular compounds? Yes?
Atomic elements.
Exactly. These are not reactive, and they would be atomic elements. And as I said, I'm going to post the lectures, so don't worry about not having the slides. I'm going to post them. Okay? Any questions? Okay. And again, I'm going to ask you in the exam, as I mentioned several times, I'm going to give you a black and white periodic table, because it won't be efficient to have colored periodic tables, simply because of that. And I asked you which of the following is not a metal, or which of the following is a metalloid. So make sure by now, I hope that every time that I have a slide, I have a purpose to have that, right? I just don't want to have more slides. Okay? So remember that you have this zigzag here, and then the first element, boron, and then here, astatine, and then here, I highlighted this, okay, or rather cross it out. Tellurium, antimony, and I did the same thing with this one. Arsenic, and germanium. These are your metalloids, and also silicon. So if you remember, and I'm going to do the highlight feature, boron and astatine, and then tellurium, and then these two, and then these two along this zigzag line. These are your metalloids. And then the elements above that are nonmetals, okay, here, plus hydrogen. The rest are metals. Okay, so make sure to know that. And I keep repeating these slides so you have more and more practice. And also, you should know, alkali metals, alkaline earth metals, halogens, noble gases, and you should know the charges associated with their corresponding cation or anion, okay? So what is the charge associated with helium? 0, right? Because as we said, noble gases are inert, so they don't gain or lose electrons. They don't want to participate in reactions. So they don't form any type of charge. What about fluorine? -1, right? Or like 1 minus, because they want to gain 1 electrons. Non-metals gain electrons. What about calcium? +2, right? Or 2 plus, because it's in group 2A, and it wants to lose 2 electrons. So make sure to know them. And also, this table, I expect you, or like this graph, I guess, the elements that are highlighted in blue, I expect you to know, especially group 1A, that they have like charge. If they form cation, because they're metals, they lose 1 electron, and they are in group 1A. And then group 2A metals lose 2 electrons, aluminum loses 3 electrons, zinc loses 2 electrons, silver loses 1 electron. So you should know them, okay? And here is the list of elements, or like some elements, some metals, that they form more than 1 type of charge. So for the previous one, they had only 1 type of charge. That's why when I tell you like potassium, what is this corresponding cation, you say K+, okay? But for these guys, they have multiple charges. And as I said, I'm not going to give you this table in the exam, but I expect you to know the anions, and by knowing anions, you can determine what is the charges of these metals. And we go through some examples today, so it becomes more clear. But remember, not all of these metals are transition metals. Tin and lead are not transition metals, but they form more than 1 type of charge. Any questions so far? And then for anions, as we said, if we have like halogens, if they form an anion because they gain electrons, we put IDE at the end. So we have like base name of the nonmetal plus IDE, fluoride, chloride, bromide, iodide, right? And then they gain 1 electron, the charge becomes -1. But for oxide, basically oxygen gains 2 electrons, and then it becomes O2 minus. The same thing with sulfur, because both of them are in group 6A. I wrote in Persian, 6A, okay? And nitrogen, as you see, is in group 5A, and it gains 3 electrons, and we call these oxide, sulfide, nitride. And as I mentioned, remember that these have like IDE at the end. You also have nitrite, nitrate, sulfate. So remember that if you have like IDE at the end, you have only 1 element, not polyatomic ion, okay? Any questions so far? Questions? Okay. And polyatomic ions I'm going to give you in the exam, but you should be familiar with them. Otherwise, you cannot solve the problems. And when I go through some examples, you see what I mean. Okay. You look at the table, OH minus, and you realize this is hydroxide. Okay. And as we mentioned, pure substances are categorized to elements, compounds. Again, I have like these slides because I want to emphasize how important they are. So we can have atomic elements, molecular elements, We can have molecular compounds, ionic compounds. Can anyone tell me what is an ionic compound? Is CO2 an ionic compound? Why not? Exactly, it's not a metal and non-metal. And be careful, we have one exception, and that is NH4 plus, which is a cation and forms an ionic compound like NH4NO3. This compound is still ionic, but it doesn't have a metal. So the general definition of ionic compounds is compounds that have one or more cations plus one or more anions, okay? But 99% of the time, they are metals plus nonmetals. So if you see a metal in your compound, necessarily you have an ionic compound. But it's possible you have an ionic compound and you don't have a metal, and that is the exception. Does that make sense? Any questions? Here, okay. And these are review, but again, I have like these slides, so refresh your memory. If we want to name ionic compounds, we write the name of the cation plus name of anion, basically. But remember, name of the anion was base name of the nonmetal plus IDE. And as I said, remember sodium chloride. If you remember sodium chloride, if I give you an ionic compound, you say, okay, sodium is just the name of the metal, chlor is kind of base name of the nonmetal plus IDE, okay? And if you give you like magnesium nitrate, you can just write it based on this, okay? I guess nitrate is it's not the best example. Magnesium nitride, okay? So if we have, and I'm going to, after I go back here, but this, I'm going to talk about the point that I just demonstrated. If you have cations that have more than one type of charge, you do the same, but you have also the charge of the cation in Roman numerals in parentheses, okay? But the procedure is like before. And if you have a polyatomic ion here, I guess I add another category here, naming ionic compounds containing a polyatomic ion. So what you do, for instance, if you have like KNO3, you write the name of the metal, so that part is the same, potassium, okay? And here, you write the name of the polyatomic ion, as simple as that. You write nitrate. And I give you the table of polyatomic ions, so you don't have to stress too much about like distinguishing them, okay? Or another example, if I give you like FeOH2. So what is this element? Exactly. And this, basically, I give you, you write hydroxide. And you realize that that is OH minus, right? And you have 2 of 1 negative charge. So you have like each OH has charge of -1, multiplied by 2 would be -2. In order for my compound to be neutral, how many positive charges Fe should have? 2, right? Because you have like 2 OH, each OH has charge of -1, right? So it has -2. So Fe should be 2 plus. Or as I mentioned before, we can write FeOH and then just switch the charges. Here 2, here's 1, right? So here, since we have 2 here, we know that it was 2 plus before. But as I said, you should be careful here because it's possible numbers cancel out. You have 2 and 4, they cancel out, become 1 and 2, so be careful. Anyway, so you write iron 2 hydroxide. So if you have polyatomic ions, you don't add ID at the end, so you don't change nitrate to nitride because nitride is already taken. So this is not how we do it. So if you have polyatomic ion, procedure would be similar to what we had before. That if you have like a cation that has only one type of charge, you write it. If they have like multiple charges, you also write the charge in Roman numerals in parentheses. And here you just write the name of polyatomic ion. Does that make sense? Questions? Okay. If no question, I'm going to review also molecular compounds and then go through some examples. And if you have the online version of the book, as I mentioned in the previous class, it was some typo regarding like tri. Your book like messed that up. And then also heptide had like the wrong number. So make sure of that. And I revised that in the previous lecture. And I also have written these myself, so make sure these are correct. And as I said, remember, mono is 1, right? Di is 2. And one time, or like sometimes in the exams, I say which of the following prefixes is not correct. And I say bi as 2. So in other contexts, those make sense, those words. But here, for like naming molecular compounds, we use di, like carbon dioxide. Okay? And as I mentioned, like sodium chloride that you remembered, or I asked you to memorize for an example for ionic compounds, if you remember carbon dioxide as an example, and that is CO2, as an example for molecular compounds, that helps you to remember the rules in exam. Because you remember that, okay, di is like 2 because you have like 2 oxygen, and then we have ox, kind of the base name of nonmetal, plus IDE, right? So basically your rule here. And if you have only one atom at the beginning, you don't write mono, okay? Like carbon dioxide. And tetra is 4, penta is 5, hexa, hepta, octa, nona, deca. And for each of these prefixes, you have like examples in our daily life that you can just, they can help you to memorize this. But overall, you should just like solve more problems and then practice so you remember these well. Any questions so far? Good? Okay, now let's solve some examples. So this is how you see the problems in the exam. I say, write the name of these compounds. And I give you the table of polyatomic ions and ask you to write the name. Can anyone help me to write the name? So what is the first one? I'm hearing sodium, right? So you see, I give you the table, but you should have worked through some examples in order to be able to use it, right? So what is the charge of sodium? And that I expect you to know. Exactly, +1 or 1+, or just plus, right? Because sodium belongs to group 1A. Okay, and something that I just wanted to mention at the beginning of the class and I forgot, if you didn't take exam 1 because of an excuse reason and your academic advisor reached out to me to reschedule, you should email me and set up a time. So if you said that you weren't feeling well, I don't reach out to you because I assume maybe you're still not feeling well, or like if you were in an athletic event and you couldn't make it up, I assume that you still have obligations, so you should reach out to me, okay? And if you didn't take exam 1, your grade shows 0 and until you make it up, okay? And if you want your grade to increase before the break, I advise you to take the test before the break, because we have like 10 days almost, or like 2 weeks after we return to the class after the break. You're going to have like exam 2, and I don't advise you to have the exams right after another. Okay, so I just wanted to mention that. Okay, so if sodium is Na2 plus and we have 2 of that, right? What should be the charge of HPO4? 2 minus, right? And also when you look at this table, you can only see 1 HPO4, right? And it has a charge of 2 minus. What is the name of it? What's that?
Hydrogen phosphate.
Exactly. Hydrogen phosphate. And as I mentioned before several times, if you're not feeling well, I ask you to stay home. Most of us are not wearing, most of you not wearing masks anymore. I'm wearing that, so. But, it's like more probable for people to get sick. So if you're not feeling well, I ask you to stay home. And sometimes students have allergies, but still, if you constantly coughing and then you show symptoms of sickness, your friends that are sitting next to you and also all class, they would be uncomfortable and then thinking they might get sick. So I ask you to stay home and just let me know that you're not feeling well. So I don't require you come to the class sick. So just be mindful of that. And I give you this in the exam and I say, is the following name correct or not? And sometimes I say, what is the name of this compound? And one of the options would be sodium 1 hydrogen phosphate. So what is wrong with the name that I just wrote? Why shouldn't I write 1 in Roman numerals in parentheses? We don't need to, right? As I mentioned, if I have like just 1 mic in the class, I don't have to, tell their last name because it's just 1, right? So sodium, if you just write sodium hydrogen phosphate, that is enough because this only have 1 type of charge. So if you write sodium 1, that would be wrong. Okay? So make sure, yeah.
Curious with the HPO4, how do we know it's 2 minus other than it says it over there, but is there a way to know that HPO4 is 2 minus?
So in the same way that, for instance, group 7A, they gained 1 electrons, what chemists did, they did like experiments in laboratory, and they realized that this polyatomic ion, basically HPO4, this unit, they tend to gain 2 electrons. And one way to learn that is basically going to the labs and do some experiments.
Okay, so it's not for us to necessarily figure out in an exam, it's just, it'll be listed, I guess.
Yes, I'll give you the polyatomic ions, so you don't have to worry about those. Question?
No.
Okay. Okay, yes.
So we only include the Roman numerals if it's a element that has multiple types of charges.
Exactly. And we do that for metals.
Thank you.
Thank you. Great question. Any other questions? Good. So what about the next one? I'm going to write this with different colors. Different color. Okay. What about this? What is the name of this compound? So what is the name of this element? Calcium, right? And one of the options in the exam can be copper, the other would be cobalt. So you should remember that Ca, and I'll give you the periodic table too, black and white version. So, but you should be able to locate elements, okay? So, what is the charge of calcium? 2 plus. So, what should be the charge of HCO3? Exactly, because -1 multiplied by 2 would be -2, and it cancels out with 2 plus. Okay? And if you go to this table, you just only see 1 HCO3, and it has charge of -1. And the name is hydrogen carbonate or bicarbonate. So you can write the name of this compound as calcium hydrogen carbonate or calcium bicarbonate. And both of these names are correct. This and this. Because it has like 2 names listed here. Any questions? Good? Good. Let's do another example. What about this? So you have SO4, you go to the polyatomic ion. So how would I know that SO4 is a polyatomic ion? What is it?
Because it's listed there.
Yes, it's listed there. So if you are comfortable with the table, that's one way to know, yes. And the other way is to see that SO4 is not like only one element, right? If it was only Cl or like N, it wasn't polyatomic ion. So you have a group of atoms bonded together and they have been mixed, or like rather they have been bonded with a metal, right? So you know this should be a polyatomic ion. But as your friend mentioned, the most efficient way is that you become kind of familiar with this table and then know that SO4 here is a polyatomic ion and the charge is 2 minus, okay? And you should pay attention because you also have like SO3 2 minus, HSO3 minus, you also have like CO3 minus. So make sure to have like the same polyatomic ion that is listed in your compound, okay? So it's SO4 2 minus, okay? So your compound, as I said, your ionic compound should be neutral, okay? So can anyone tell me what should be the charge of Sn?
4.
Exactly, right? Because you have like the charge of SO4 is 2 minus, right? And you have 2 of that. So 2 multiplied by 2 minus is 4 minus. So the charge of, I'm going to write that, charge of your cation should be 4 plus, Sn 4 plus, okay? So now, can anyone tell me the name of this compound? 10, okay? What else? I have kind of this highlighted for you. Uh-huh. Yeah, sulfate. But what is missing? Exactly, right? Because tin was one of the elements that has multiple types of charge. Any questions so far? Are we good with this example? Okay. What about the next one? So what is C2H3O2? What is this charge? And I kind of help you.
-1.
Exactly. And what is the name?
Acetate.
Exactly. So what is Pb? Looking at your periodic table.
What?
Exactly. Pb is lead, right? Can anyone see that in the board, in the periodic table here? Going back here, so we have lead and acetate. But what is charge of lead? Exactly. You have like 2 acetate here. Each of them has charge of -1, right? Would be -2. So this charge should be +2. Is that clear? Any questions? Let me see. Okay. Now reverse. I give you, I guess I should say, write the molecular, or like, not molecular, write the chemical formula. I guess I can say it to be more broad. Chemical formula of these compounds. So what is copper? What is the atomic symbol? Cu, right? And remember, you have it like in the, here, it's like in group 11, right? In transition metals. So don't confuse that with CO, Cl, Ca, Cs. You have like multiple ones. And before writing the chemical formula, I advise you to just like write each of these individually. So what is copper 1? Cu plus, right? So what is chloride? Cl minus, right? So copper 1 chloride would be Cu, Cl. Any questions? What about potassium permanganate? What is permanganate? MnO4 minus, and potassium is K plus, right? So it would be K MnO4. Are we comfortable writing this? Any questions? I think okay. Okay, what about molecular compounds? So how do you write the molecular formula of chlorine monoxide? So chlorine is Cl, right? So here you have mono plus ox, kind of like base name of nonmetal, plus ide, or you just can remember that oxide is O2 minus, right? So chlorine, remember, if you don't have any prefix before chlorine, it means that it was mono, it was 1. So it would be chlorine monoxide. So you have 1 oxygen. So this would be ClO, chlorine monoxide. Is that clear? Any questions? So yes.
Okay, so I know you said oxide is O2 negative or whatever. So how come you don't write it in the molecular formula? Like, is it just because you don't need to? Does it cancel out with something that chlorine has?
Yeah, that is because I just made a mistake. So thanks for catching that. So oxide, O2 minus, is for ionic compounds. Great catch, thank you. Okay, so remember, for molecular compounds, we have like, so prefix plus name of first non-metal, or it can be metalloid too. So plus, it's more important to not be a metal, okay? Because we have boron, right? We had like an example of boron. What was it? BCl3, boron trichloride, right? And plus another prefix plus base name of second non-metal plus IDE. Great catch. Okay. So what about diboron tetrachloride? So what is boron? Exactly. What is di? What is tetra? What is chlorine if it was just like the base name of chlorine, right? So chloride, you know that it has been chlorine. What is the atomic symbol?
Cl.
Right? So what would be this compound? Right? So we say diboron tetrachloride. Are we good with writing these? Any questions? Yes?
I have a question. This is the chlorine monoxide. Maybe I'm not incredibly understanding of. I guess we don't need to write the charges for like chlorine, for example, being -1 or.
Yes, these are molecular compounds, so you don't have charges. Yes, exactly. Great question. Any other questions? So still, all the compounds, they have like imaginary charge that we call that oxidation state, but I'm not going to talk about them in this class. So for that matter, for molecular compounds, you don't deal with charges. Okay? So finally, let's practice the other way around. So you have like the name of you have like a molecular formula, and I asked you to name the compound. And I also included the periodic table and these prefixes here. So you should know the prefixes for the exam, but I give you the periodic table. So I just wrote this here so you participate in the lecture and then help me to write this name. Okay. Can you say it? Phosphorus triiodide. Okay. So you write, because you have one at the beginning, you don't write mono, you write phosphorus. Tri, you have 3. Iodine, you write the base name of non-metal plus IDE. I guess IDE here. Okay. Any questions? What about the next one? Nitrogen, right? And then what is Se? Selenium, right? But how many do you have of that? Tetra. So you have di prefix plus name of the first nonmetal, tetra. Tetra, and then selenide, I guess. Selenide. That is the correct way of writing this. Selenide. Yes?
Is nitrogen already like diatomic, so the di behind nitrogen would be like redundant? Like, would you just write nitrogen tetraselenide?
So you're talking about this one?
Like it's already into inherently metal.
So shouldn't I write di? Is it?
Yeah, like so it's N2SE4.
Uh-huh.
So it's, nitrogen's already inherently like diatomic. Would you just need nitrogen instead of dinitrogen? Wouldn't that make it like N4 instead of like?
So if you only had, that is a great question. So what your friend asks is that, why should we write? So if we have nitrogen, it exists as molecular element, so why should we write dinitrogen? And the reason is that if we only have, it's kind of like CO2, right? So oxygen by itself is O2, but when you have carbon attached to it, it's not molecular oxygen anymore. So here, if you have the molecular structure of this compound, it's totally different from nitrogen itself. So that's why we should write dinitrogen. Does that make sense? Great question. Any other questions? Okay, periodic table here. Okay. Right? So this is good if you kind of like memorize elements in some level, it would be easier for you to find that in the exam. And I had like the periodic table to help us kind of write the names, but I also included the mini version in the previous. Now I can use the table that I had here. So here you have like atomic mass for each element, and then we learned how to calculate that. And then if you didn't solve the homework yet, you see some examples of how to, or one example for each homework to calculate that. But now we're interested to know mass of a compound. So how we calculate that is the following in the next slide. And before I just like throw the answer at you, how do you think I should calculate the mass of a compound? So if I have like CO2, what do you think would be the mass of CO2 based on mass of each element that I have here? So I have oxygen here and carbon here. So if I want to calculate mass of CO2, it just makes sense that I add the masses of constituents, right? Otherwise, it wouldn't make sense. If someone asks me, what is the performance of your students in 101, and then I give them for some other class, it doesn't make sense, right? I should consider performance of each individual student in this class. So the same with the compound. If someone asks me, what is the mass of this compound, I should consider mass of elements in it, right? But depending on how many of those elements I have in that compound, the mass changes, right? So mass of CO and CO2 won't be the same, right? So what is the difference in their mass? Extra oxygen, exactly, right? So in general, so here you read this number, 16, and then here you read this number, 12, 16, and that is your atomic mass. So remember, in periodic table, the number listed below the element is atomic mass. The number above is atomic number. So don't have them confused. So now I'm going to talk about formula mass. If you're comfortable naming compounds, and as I said, you have like also naming acids, but I want you guys to be comfortable naming molecular and ionic compounds before throwing more naming at you. So now I'm going to talk about formula mass. And formula mass is basically mass of a molecule or an ionic compound, so mass of compounds. So now, previously in the class, we talked about mass of each element, right? And I guess to calculate the mass of a compound, we call that molecular mass or molecular weight or formula mass. All of them are synonymous. I have number of atoms of first element in chemical formula multiplied by atomic mass of first element. So in the case of CO2 would be mass of number of carbon atoms, which is 1, multiplied by mass of carbon. And I find that in periodic table, right? Plus number of atoms of second element in chemical formula. So for instance, here I have 2 oxygen, 2 multiplied by atomic mass of second element. And then if I have like 3 elements, I do the same for the third one or fourth and so on and so forth. But for the case of CO2, I go to the back to the periodic table and I see that for carbon, this number is 12.01. And depending on what periodic table you use, the decimal points would be slightly different. For instance, here, the number for oxygen is 15.999, but in your book is 16.00. But either of those you use, you get the same number. So don't worry about that. Plus 2 multiplied by 16.00. Okay. And then you have like 12.01 plus 32, which would be 44.01. And that would be atomic mass unit, or AMU. Any questions? Good. Okay, so continuing chapter 6, I talked about nails and their analogy with mole. Okay, so I told you that if you want to buy some nails, instead of buying one by one, you usually just ask for like bunch of them, and the person that wants to sell it to you, they just like, measure their mass, right? And then give you like 5 pounds or like 0.5 pounds, depending on how much you want. And for you to know exactly how many nails you purchase, how do you think they tell you the answer? And we talked about that in the last class, and I have the answer written here. Can anyone explain that to me? They measure the mass of 12 of them and report the mass. Okay? They say like 1 dozen of nails have this much of mass. And then we know that dozen means 12, right? So any number that you purchase, or like whatever the gram or like pounds, depending on what system of units you're working on, you purchase, you can convert to numbers. So for instance, if I say that I purchased like 0.5 pounds of nails, how would I know how many nails, number of nails I bought? Remember conversion factors? So the thing that you want to calculate, you write question mark number of nails equals the thing that is given, 0.5 pounds. And then you convert pounds, and you remember that you want these two guys cancel out. And then you have this conversion factor here to 1 dozen of nails. And you know 1 dozen, the mass of 1 dozen is 0.150. And you know that 1 dozen of nails equals 12. So 1 dozen means 12 nails, right? And that would be 0.5 multiplied by 12 divided by 0.150 number of nails. Does that make sense? And we still have the attendance, so if you just leave, you don't get the attendance. And the same thing with the moles. So the way that we can measure atoms is by mole. Because atoms are so small, we cannot just count 1 atom, 2 atoms. We should have 6.022 multiplied by 23 of them. So this is basically our dozen. But in the scale of, atomic world. So we call 1 mole of anything 6.022 multiplied by 10 to the power of 23 of that thing. And remember, this is not only specific to chemistry. It can be, we can have 1 mole of horses. I mean, that is not that applicable because this number is really, really large, okay? But I expect you to know the magnitude of mole. Okay, so if no question, you can just do the attendance and then go to your next class or lunch or whatever you're doing after this.